So my name is Lisa Anne Floyd, and I'm grateful for this opportunity to share some of the stuff that I've been working on. I feel like I've pulled some stuff out of a vault because I haven't presented recently on mathematics, mostly because here in Ontario, we've had this new science and technology curriculum, as well as the grade 9 math and grade 9 science curriculum have been all updated. And so I've been spending a lot of time, investing a lot of time focusing on those curriculums. So it was kind of nice to go back to prepare for this webinar, looking at some of the stuff that I've made over the years. And so I've selected some of the things that I think work best. I've tried to do new things, but I feel like there's some stuff that have been tried and tested. And so I'm recommending that to you. So some of the things that we will be taking a look at today so the whole time, I'm just going to share a whole bunch of examples for grades 4 to 8 in Scratch. And I'll also be, as I'm going through all those examples, I'll be highlighting the curriculum. So there's a bit of a coding continuum in grades 1 to 8. And of course, this is directed towards grades 4 to 8. However, students will need to have an understanding of those concepts in grades 1 to 3 before they come to you in grade 4. And that not necessarily that might not have happened necessarily just because, they haven't been doing coding since grade 1. Also, I'll highlight some of the consistent topics. So across all the grades, there's some stuff that's done in every grade. So I think focusing on that, and that's actually what is in the overall expectation anyway, which is what we are required to evaluate. So that helps, I think, when we have a new curriculum to focus on those overall expectations. I'll also share a few assessment examples, some little assessment cards that I made up. So you're welcome to adapt those for your own practice. So as I mentioned, there is only one overall expectation for every grade, and it's the same for grades 1 to 8. So maybe that might make you feel a little bit better when you think about doing coding. If you haven't done a lot of coding, or if you have done some coding, it doesn't necessarily mean you have to do a whole bunch, because there's only one overall expectation. And again, it's the same from grades 1 to 8. And the overall expectations are the only thing that you have to evaluate. Of course, we must account for the specific expectations in our instruction and in our assessment, but evaluation should focus on the overall expectations. So focusing on students' achievement in the overall expectations. Now, there are only 2 specific expectations per grade, and keep in mind, there are about 45 or so expectations per grade, and only 2 are coding. The ones that, or the part that's consistent across every grade is what I've highlighted here. So focusing on creating computational representation, so doing some sort of coding of a math representation, and I'll show exactly what that means by just writing and executing code. In this case, we're going to be doing this with Scratch, so we'll be dragging some blocks off onto our screen, and that will be writing. And then when we execute the code by hitting that green flag, that's what it is. Running the code is executing the code. That second expectation is my favorite. Reading and altering existing code. You don't always have to have students starting from scratch. You can have them share a link and they can alter the code, or you can do a screen print of code, which I think works really well for assessment purposes. And then they can predict what will happen when they click that green flag. There's some powerful learning that can happen when you're doing that. Some really focusing on inquiry and thinking skills when we're predicting what's going to happen when you run the code. So although this webinar, as I mentioned, is focused on grades 4 to 8, the coding concepts are cumulative. So we do have to take a look at what students are doing before they come to you in grade 4. And like I said, they might not have been doing that yet. It may be in a few years from now, they will have that prior experience. So taking a look at in grade 1, sequential events. So that just means one line of code after another. And I'll show an example of this when we're doing some live coding in a moment. Concurrent events in grade 2. In this case, I have one sprite, one character drawing a triangle and one drawing a square. So when you hit the green flag, that's what happens. 2 things are happening at the same time. And then in grade 3, students are expected to be assessed on their ability to use repeated events. So if I zoom in onto my code here, you can see I drew a triangle earlier without a repeat. So I went straight, I rotated, I went straight, I rotated, I went straight. So I did that 3 times. And so rather than doing that 3 times, I can just use a repeat. So I can be much more efficient. And I don't think you should stop students from using repeats in the younger grades if they're ready. They enjoy them. And I tend to use Scratch Junior a lot and Bebot for grades 1 to 3. But I've also used Scratch, what we're going to be focusing on today, in some of those younger grades as well. So there we've got the sequential, concurrent, and repeating events. You can see, so in grades 1, grade 2, grade 3, and then in grade 4, we'll add to this chart as we make our way through the webinar. So I always like to start off with a simple square, no matter what grade I'm focusing on, even in grade 9. So it might seem really simple, but there's just so much that they can do with it. So it has this low floor and high ceiling. They're able to extend it to whatever they want. And also by starting with the code, it's a little more accessible because I find when I draw the square with the students, it takes a while. And so by just giving them the code and then letting them play around with it, they're really focusing as well on the mathematics. So I'm going to do that now. I'll start off by drawing a square. Or I'll show that actually in a second. So once I get to the link, I'm going to walk you through some challenges. So typically what I'll do in a classroom is I will, or at a PD session, if you're going to be supporting teachers with this, I will have this slide up with the challenges. So the first challenge is, can you make the side length smaller? So they'll run the code first, see what it looks like, and then try to make the side length smaller. And then the second challenge is, can you make the shape shown? So you can see that there's a shape that's sort of like an upside down and backwards L. And then the third challenge is, can you change the shape to a triangle? So I have all of those challenges up on the board. So then if a student is done the first one, they don't have to wait for the next instruction, because that can be boring. So we want to push their thinking right away. And then you can see I have some other challenges at the bottom. So once they make a triangle, if they're still waiting, then they can go ahead and make a hexagon, a pentagon, or a rectangle. And there's a lot of different challenges that they'll start to just play around. And then one student will see someone else's screen and they'll start to try and make that. So it's kind of like a domino effect. And it's quite interesting to see what happens. Usually there's different shapes all over the place. And then also every time I'll do this, I'll see different shapes created. So you can see on the slide that I'll give the students, and they also have the link. So the top part, they'll be keeping on this, they will not be changing. And then the bottom part is what they need to alter to do all of these challenges. So I'll work my way through quickly. Of course, it would be much slower if you're doing this with students, because one, they might not have done this before. And it does require some trial and error. Test this out. It doesn't matter if they break it, they can just go back to the link and try it again. So that's what's neat about coding as well. It gives that immediate feedback. It's dynamic in nature. And that's two of the really awesome affordances of coding, and why I think we shouldn't be really doing much unplugged. I mean, a little bit of unplugged is okay, but get students doing the coding. So here's my square. You can see that I made my code a little bit bigger by clicking on this little plus thing on the bottom right-hand side of the code editing window. You can see the part at the top. So if I just click the green flag to run, you can see the square is drawn on my stage. So regardless of their prior experience, everybody can work with this code. You just click the green flag and see what happens. My little character, in this case, I used an arrow so that you can see the direction that the arrow is going. So if I just take a look at the actual square, we know that there are 4 sides to a square. We go straight 100 steps, which is pretty small, as you can see in Scratch World. Then we pause for a quarter of a second, just so that you can see it happening. Otherwise, it would happen really fast. And then we rotate 90 degrees because there are 90 degrees on each angle in a square. And then we pause again, just a quarter of a second, so that you can see the square being drawn. The top part of the code, all it is kind of resetting that sprite. So it moves the square to the center of the screen. You can see here it's pointing to the right direction. I like this because it has like a little compass. So if you're pointing towards the 90 degrees, then that's the right direction. And then, as I said, 0, 0 is the center of the screen. It is a Cartesian plane. So 0, 0 is right there. Erase anything that was on the screen prior. So when I start this, it erases that previous square, and then I put my pen down. So the little sprite will drag its butt and leave a mark wherever it goes. So just remembering what my challenges were. My first challenge was to make the square smaller, the side length smaller. So using those terms from the math curriculum. So instead of moving 100 steps, a lot of times students will just change that to 50. Then they run the code, they get the immediate feedback, their square is now smaller. That second challenge was to make kind of like an upside down L. So in that case, well, I'll just change it back to 100. So it's the same length, side length, and I'll change it to repeat 2 now. So if I just repeat 2, I've got my upside down kind of backwards L. My third challenge was to make a triangle. Now, this usually takes a while for people to figure out. They usually get that we need to change the repeat to 3 because there are 3 sides in a triangle, and they knew that before we had 4 and there was 4 sides to a square. So if we just do that, we've got the 3 sides, but now obviously we must change the angle. So typically what teachers and students will do is change that to 60 because they might be aware that the interior angle of a triangle is 60 degrees. And so they'll try that and they'll be like, oh, that looks more like a hexagon. So eventually, even without understanding, and I'll explain, why it's 60 and why it's 120, you might have made that connection that it's actually the exterior angle. So we are connecting to the supplementary angle rule, which I'll get to, which we do in grade 6. But just without even having to talk about the supplementary angle rule with younger students, and sometimes I'll talk individually about it with a few students. But if we change it to 120, which they will get eventually anyway, like even if they change it to 100, here you'll see that they're getting close to a triangle, but it's not quite closed yet. So they'll just keep increasing that value until they get a nice triangle. And then the other challenges you can try out if you'd like. You'll have the links. Again, I just want to mention all the links for the code and for every application I share will be on a document at the end. So you're welcome to try that out. And of course, you'll see the bit.ly that I've shared with you. So I'm going to return back to my PowerPoint here. So you can see that we've managed to do grade 1 expectation in there because we have sequential code, one line of code after another. And actually inside of that repeat as well, we do have some sequential code too. And then, so that's in grade 1. And I have that thing in the background, the curriculum in the background, because I went to the curriculum website and then I just looked at compare grades. So I find that feature really useful, especially in the mathematics curriculum, because almost everything is like a continuum. So you know where your students are coming from and where they're going. So then also what we did there is we looked at something that we do in grade 3, which is we included a repeating event. So there was a repeating event. So let's just quick reminder. So far, you've passed grade 3 now. Actually, we did do, as I mentioned, some stuff that could be considered in grade 6 or is in supplementary angle rule. But so far for coding, we've got grade 1, sequential, grade 2, concurrent events, and then grade 3, we've got those repeating events. So the grade 4 expectation, as I mentioned, well, actually every expectation from grades 1 to 8, the second one, C3.2, which you'll see in every grade, says read and alter existing code. So that's what we did there. I gave you the link to some code to make a simple square, and then we altered it. So reading and altering existing code is really useful. It saves you time. You're not having to mess around with a whole bunch of blocks. They get right into the coding and then they can alter it. And those that want to play around a little bit more, they have that flexibility as well. So reading and altering code, that was like a big piece of what we did there. And you can see, again, it's just, it's really small, I know, but grade 1, grade 2, grade 3, and you see that all the way to grade 8, reading and altering existing code. Now we're moving into grade 4. So in grade 4, my favorite way to teach nested events. So nested events are when we have some sort of event inside of another. That might be conditional statements, which we'll go over in a bit when we go to grade 5, inside of a repeat. In this case, we have a repeat inside of another repeat. So let's just take a look at what that looks like. Lost my square. There we go. All right, so I'm going to go to my simple square code that we were just playing around with. And notice that I am not signed in. So your students do not have to be signed in to do any of this. I do find often I'm visiting schools like just one time, so it takes too long, I find, to sign in, so I don't bother. But students might have an account, and if they do, then they could remix. So there'll be a little button that says remix, and then it will save their program and in their Scratch account, and then they'll have access to it. But again, it's not necessary to be signed in to Scratch. So here's my square code. If I run it like that, you'll see the square. I'm going to take out the wait blocks because you'll see in a second that it goes too slowly. And usually I wait for the students to recognize that, oh, the wait blocks are causing it to go too slow, and they'll just remove them themselves. But I just took them out there to save some time right now. So as I said, we're putting a repeat inside of another repeat. So what we're going to do is we're going to draw a square, rotate a little, draw another square, rotate a little, and do that 10 times. So I'll grab a repeat, and because we're doing it 10 times, we'll keep that repeat 10. So I'm just going to put my repeat inside of the other repeat. And as I said, we're going to rotate in between each of those. So I'm drawing a square, then I'm rotating. Drawing a square, rotating, drawing a square, rotating, and do that 10 times. But I don't want to rotate 15 degrees. I'm going to rotate 36 degrees. So let's just try that out. Now you can see my beautiful picture of a square. You can see that I've got nested event, one repeat inside of another. So we're connecting to that grade 4 expectation with some geometry here. Something else that I think is fun to do is to change the pen color by 10. So there are 200 different colors in Scratch. So if I also change the pen color, it will just change the shade a little bit, or change the color a little bit. And you just makes a nicer picture. A couple things to point out here is the 36 and the 10, those numbers are significant. So repeat of 10, and in between each square, we rotate 36 degrees. And that made us have a complete circle of squares because there's 360 degrees in a circle. So you just have to have two numbers that multiply together to make 360. So I could actually change my repeat to 36 and then change my rotation to 10. So 36 times 10 is still 360. And then it just makes a tighter spiral kind of looking thing, sort of a spiral. We could make a spiral as well, but that would require an accumulator. Maybe you can do that sometime. That'd be a good challenge. So we've got a little bit of a tighter square. And of course, some students will repeat 360 times and rotate 1 degree, or maybe they'll do 3,600 and rotate 0.1 degree. Then they go outside for recess and come back in, and they have this really cool picture on their screen. They're usually excited to see what happens. So there's a nested events in grade 4. So now we're through the grade 4. Nested events is the new skill. So again, there's only one new skill, except for in grade 7, there are a ton of 2 per grade. And then in grade 6, we don't actually add a new skill. We just make our code more efficient. So nested events, we're making our way through the continuum of skills that students are expected to do in each grade. Just to mention some cross-strand connections here. I did touch upon this earlier, but we are connecting to the supplementary angle rule and exterior and interior angles, which are addressing the grade 6 expectations. And also in grade 5, students use protractors and measure and construct angles up to 180 degrees. So it's also relevant to them. But in grade 6, it is the supplementary angle rule. So as I mentioned, most people or teachers anyway know that there are 60 degrees inside that triangle. So the interior angles of an equilateral triangle are all 60 degrees. So that is, if I measure the angle, would be 60 there. And so one way to help stress this when students are a little bit confused is to just get them to stand up and walk the triangle. And you'll find that when they walk the triangle, they realize, oh, wait, in order to close the triangle, they have to turn more than 60 degrees, more than 100 degrees, and actually 120. So if you measure that angle, so 60 inside, 120 outside. So if we put our protractor like that, I think it's worth, and especially in grade 6, demonstrating this or talking about this. So if I were to extend that line, it would be 120 there. And then 120 plus 60 is 180 degrees. So therefore, the exterior angle is what we're walking. When we're walking shapes, it's the outside angle that we're looking at. And if we're not sure what that is, we could figure out what the inside angle is and then subtract from 180 to determine what the exterior angle is. So here I have a chart that perhaps the students can complete this. So you can leave some of this blank through making their shapes in Scratch. So they might get those. So for example, the pentagon's a little trickier. They have trouble getting that one. And then they can keep trying until they get it. And then they'll realize it's 72 for the exterior angles if they didn't know. And then they can fill out the chart. Of course, there's also, to determine what the exterior angle is just 360 divided by the number of sides or the number of angles in a shape to get that exterior angle. Then they could calculate the interior angle from that information as well. Okay, so here's just something that both my husband and I created. I think it was like 6 or 7 years ago when we first started trying to connect to students in elementary schools in the younger grades, because we were both teaching high school computer science, and we recognized that it would be great if students started doing this a little sooner. So if I just go to that link to show you, again, this link will be shared for you. We've got little shape certificates. So the top one is en français, and then the bottom one, we've got the English version. So you can see we have the code for them in the center of the screen there. And then they just go into Scratch, so they could recreate that, or you could give them the link to the starter code. And then they just choose which shapes they would like to do. Some are much more challenging than others to do. You can see the stars is pretty tricky, but they're using the same kind of premise, the same sort of blocks of code to create all of those shapes. And it's sort of a little bit of an extrinsic motivation, and also for differentiation, because some students will prefer to, they also get a bit of choice too. Some might prefer to make a hexagon or circle, whereas some might want to go ahead and try that rhombus or the star. So you're giving them a chance to try something that they'd like to focus on. I just have them color them in as they complete them, and then I initial once they show it to me. Okay, what do I have next here? Right, so debugging. This is one of my favorite activities, once again, to do. I thought it was important to share this with you. I know some of you might have used it before. So I have this document for debugging. So I send the students to the link. And when you get to the link, you'll see that it talks about Beetle and trying to draw some shapes by coding them. But unfortunately, Beetle has made a few errors. Well, fortunately for our learning anyway. And then there are a number of links I added to these if you saw an older version a few years ago. So they do get a little progressively more challenging. So for some students, I'll just say, why don't you start at number 6 and then work backwards? I do that a lot actually in math class, starting at the end and move backwards, because those questions tend to take longer anyway. So students aren't sitting around having to do something they already know how to do. Don't like to waste their time. So I'm going to start with the first one though, which is debugging a square. You can see that I have instructions in a little comment. So to add a comment to a Scratch program, you just right click and add a comment. It says, oh no, Beetle has made an error. Can you debug this program so that Beetle draws what they intended? So if I run the code right now, it says, watch me draw a square. And then you can see it's not quite a square. So the students will be able to figure out that, well, it moved 80 degrees, so we need it to rotate 90 degrees. So therefore, you can go ahead and change that to 90. Whoops. And rotate. Okay. So I'm going to go back to my slide here. So again, there are a number of challenges there for you to try out, and they get a little bit more fun, I think. Some hard fun, as Seymour Papert would say. All right, so there's my debugging example. I already showed you that, so I'll just keep going. So speaking of Seymour Papert, who did say the term hard fun, that coding gives us the, challenges, but it's fun to have challenges. If you already know the ending, then it's not very exciting. So we want to be challenged a little bit. So here's a number of quotes that I love that Seymour Papert says in this book called Mindstorms. He wrote a number of books. This one was, well, you'll actually recognize that Mindstorms is what they called the Lego kits. So it was named after this book. Typically in my math class, a child's reaction to a wrong answer is to try to forget it as fast as possible. We all recognize that as teachers. We see that happening. Perhaps we do it ourselves. In coding, the programmer is encouraged to study the bug rather than forget the error. And I think anyone who's done coding in their class have seen this for yourself. It's just so powerful. Students cannot figure out what the error is. They crowd around the screen. They all work together, and they just naturally want to figure it out. And it's especially powerful when it's mathematics, because then now they're starting to focus a little bit more on math. I've mentioned before as well in math, I sometimes actually like when students use pen to write, and then if they make a mistake, rather than erasing it all, if they feel comfortable with this, I know that there's some evidence as well that maybe they should be working with non-permanent services. But I think if we foster this mindset of where mistakes are part of the learning, part of the process, they can just draw a line through it and then continue. And then when I walk around the room, I can figure out where they went wrong, and I can imagine their thinking, and I can support the students better. And we can talk about it too as I walk around. I just wanted to share this little challenge that we did with a class. We called it geometric mindfulness. So I'm just going to run this program here. Oops, sorry, I stopped it. Keep going. So you get the idea. We're just drawing a bunch of shapes with a black background. So I think it's pretty neat. They were making, eventually they made like screensavers. That was the idea, to something that was kind of pleasing to the eye, and they added music to it. So moving on to grade 5 now. So in grade 5, we have conditional statements, which are introduced. So we've got the sequential in grade 1, the concurrent in grade 2, the repeating events in grade 3, nested events in grade 4. Now we're onto conditional statements, but keep in mind, we still have students writing code for math situations. That's the key overall expectation that we want them to do. And then reading and altering code, and then predicting what the code is. So moving to the next one. So conditional statements, I always like to use this example when I'm explaining conditional statements to students. So with conditionals, programs can make decisions just like we do, but they use something called conditional statements, also known as like selection. So if it's raining, then bring an umbrella. So if is like the part of the conditional statement. The condition is it's raining, then is part of the conditional statement. The action that you're going to do as a result of that condition, if this condition is true here, is to bring an umbrella. So the way we would write that in like pseudocode, so sort of a mixture between English and programming code, helps us to plan out our program sometimes, and then you can write it in any language. But this is the standard format. So if something, so whatever that is true, then do this. And if, or you can even add an else. So if this is true, then do this. Else just means otherwise. So if that's false, then you do the otherwise clause, something else. So I've got a couple of examples here on the bottom here. If your age is greater than 19, or so I have a Boolean operator as well there, or your age is less than 13, then you are not a teenager. Otherwise, you are a teenager. So there's my else. Sorry if you can hear the background. I have a 1-year-old, and then my 3 boys are attempting to keep her happy right now. I think she's trying to escape. She's trying to get in. Then I've got over here on the right, if the temperature is greater than 20, then we wear shorts. So if our conditions, if that's true, the condition is greater than 20, then we wear shorts. Else if means, okay, if that's false, then we look at the next line. We don't move down until we check if this next line is false. If this is false, then we move to the otherwise clause. And it's good practice to always have an otherwise clause. So it's not necessary, but it's good practice to do that. So now let's take a look at a simple Scratch program that I made. Again, I'll share this with you at the end. You can see that if the character, so if my little Scratch character is touching the color green, then it will say grass. And this is sort of like an else if, because in Scratch it doesn't say else if. It's if the character is touching blue, then it'll say sky. And if they're touching that little brown color, then it will say ground. So now I'm going to run this code here. So you can see I also added it so that when you press the up arrow, the down arrow, the left arrow, and the right arrow, which actually is a good application of the Cartesian plane, because if you go to the right, you're adding 10. If you go to the left, you're subtracting 10. If you only go up by 1, then it just moves a little bit. So you want it to go up a little more. So that's why we're using 10. So we're changing x by 10, changing x by negative 10 to go to the left, make that bigger, changing y by 10, changing y by negative 10 to go down. And then for my program there, you would have noticed that as I moved the character around, the speech bubble changed. So just a simple application to demonstrate conditional statements. But what we're supposed to do is connect it to math situations, of course. But it's good to introduce concepts, I think, to kind of reduce that cognitive load of focusing on something a little simpler. Or it could be a math concept that the students, like when we were doing 2-dimensional shapes, something that students tend to be more familiar with. So now we've got nested events in grade 4, conditional statements in grade 5. Taking a little bit more of a look at conditional statements, I just want to share this resource that I created for TVO. I know Maureen from TVO is on here, so thanks for joining. But one thing that we've found is for conditional statements, it's a good opportunity or good time for you to also introduce variables. So because you usually are looking at values when you're using conditional statements, you're looking to see if something is true or if something's greater than another number or something like that. So what I've done is I made this quick introduction to how to make a variable. And when we do this, all it is doing in this program, this particular program, is adding 2 numbers together and outputting. So whatever numbers the students input, it will output the addition or add those 2 numbers added together. And then the challenge is for them to change this to a multiplication program. So I'll just demonstrate that. So it says, I will add 2 numbers. What's your first number? So I have a variable called num1. I enter 4. And then I store the second number in a variable called num2. I enter 3. And then when I click on the check mark, it outputs the answer, which is 7. So the sum of those 2 numbers. So in that resource, which the link will be on the document that I'll share, but there are a number of activities, articles, all related to the math curriculum grades 1 to 9 and the science and technology grades 1 to 9. And so when you go to that link, I'll just show you the one that we were looking at right there, because it's a junior resource. It will be under junior and creating an addition game with conditional statements and variables. So that's the one there. You'll see when you get to that, that there's a teacher guide and there's also a student activity page. So you can actually just direct them directly to the student activity page. And then on the teacher page, I have the solutions for you there. If you click on this student page, this is what the students will see. There's a tutorial walking you through how to do that program. There's some questions, there's some extensions, and then there's a part 2, and it uses a bit of pseudocode, which you'll see a lot on EQAO questions. So that's quite useful, I find, sometimes, like showing them, what is pseudocode, and then actually doing the real coding, I think is valuable. So moving on to, so this is part of the same resource. Okay, so part 2 is when they actually make the game. So part 1 is just showing them how to add 2 numbers together and output the answer. Part 2 is where it's a game and you output 2 numbers for the user, and then they have to go ahead and input what they think the answer is, and it will check if their answer is correct. So what is the sum of these 2 numbers? 9. Yes, that's correct. Then I'll play that again. What's the sum of these 2 numbers? I think I answered it incorrectly here. 10. It's 8 and 3, so it's not 10. So it does tell you what the correct answer is. And if you look at the code, you will see that we had a conditional statement and we used variables. So if the sum is equal to what the user entered, then they were correct. Else means otherwise. They were either correct or they weren't correct. So I didn't have to use an else if, and it told them that they were incorrect. So that's, whoops, that was, there we go. So that was a resource that you might want to check out for conditional statements. Okay. So I'm just going to show a few more examples related to conditional statements in grade 5, but in a cross-strand way. So we'll look at probability right now. So in grade 5, we're supposed to look at the probability of events happening. And then you can represent this probability through a number line or probability line rather. But the second expectation also is comparing the theoretical and experimental probabilities of an event happening. So we can actually go ahead and do this through code. This example is having I created an application where it's flipping a coin and it's going to do heads or tails, but I've also incorporated the experimental probability. So you can see that I keep track of the number of heads, keep track of the total flips with a variable, make it a little bigger, total flips. And then all I do is divide the total heads by the total flips to get the experimental probability. Whoops. So when I run that, you can see that the more times we flip it, the closer and closer the experimental probability gets to the theoretical probability. And if we want to extend upon that application, this maybe is more in grade 8 because we're actually generating our own data now and making decisions. So for this one, we're doing the same thing for the heads and the tails, experimental probability of heads rather, but then you can make it so that instead of just flipping one time, it will flip. In this case, I have it set to 10 times, so then I can run that code. So it will do 10 flips really fast, but then maybe you don't want to do 10, maybe you want to do 100. So you can see that experimental probability getting much closer to the theoretical probability. I know it's really small, but trust me, it is. But then you can actually go to edit and go into turn on the turbo mode and change the number of repeats. Oh, if I do that, I'll just fast forward. There you go. And you can change the number of repeats to a really high number in the code. So instead of flipping 100 times now, I'm going to flip 1,000 and it will do it like that instantaneously. And then they can see almost instantaneously. And then they can see that the experimental probability is now at 0.49. So it's much closer to the theoretical probability. And of course, you'll have students change that to a really, really big number. And then they'll try that out. So something for you to check out. Again, you'll have that code. Also, what they might do is you could challenge students to make a weighted coin. So in my code, I have it like generate a random number between 0 and 1. If it's 0, put a heads up. So that's the conditional statement. Otherwise, display a tails and keep track of those heads and tails. But what you could do is generate a random number between 0 and 2. So then we've got 0, 1, and 2. And then you've got 3 options and you can make it so if it's 0 or 1, display a head, otherwise display a tail. And that would be that it's like going to be weighted now. So you're way more chance, or not way more, but more chance of getting 2/3 more chance of getting a heads than a tail. So it's just, you could challenge them to turn into a weighted coin without saying anything and see if they can do that. There's always something you can challenge your students with, and as you become more comfortable with coding, and I notice this with myself, every year I can come up with more challenges for my students because I've seen other students do it. So let's make a couple connections now to spatial sense and financial literacy. This program is just, I usually give them a template like blank like this with angles. So it's saying if the angle is greater than 90, then tell them that it is obtuse. If it's less than 90, it will be acute. If it's equal to 90, then it's a right angle triangle. So the students can fill that in. So you can run that code. I'm typing in 200 here, out of range because I asked them for a number between 0 and 180. So I actually did some input validation there so that I often do that for students when they make a program. I'll do something that I know won't work and I'll mess them up. They have to go back and fix their code to take that into account because you don't know what people will enter in. So that's just a simple program for checking out angles with conditional statements. Financial literacy. I know this is really small on your screen, but you'll have access to all of these links. I just want you to be aware of the possibilities. So it looks like a lot of code, but all I'm doing is asking for the price of the first item and asking for the price of the second item and how many you get for that item for each one. And then it calculates the unit rates, which we do have to do in grade 5, calculate the unit rates for various goods and services, and then identify which is the best value. So it does tell you with a conditional statement, if unit rate 1 is greater than unit rate 2, then item 2 is the better value. So it actually gives them that information. Now moving on to grade 6. So in grade 6, as I mentioned earlier, all it is, there's no new concepts. However, the students are supposed to focus on making their code more efficient. So here you can see I've got 2 of the same thing here. How about we just look at that code here? I'll make it bigger. So I have 2 scripts of code here. And if I click on the first one, so if I click on this one up here, it'll run every script. So I only want to run one of them at a time. So I'm going to click on the green flag in the actual code editing window, and that will draw a triangle. That's a lot of steps. If I click on the second one, it also draws a triangle, but with fewer steps because I used a repeat. So that's one way to make your code more efficient. All right, so we've got nested events in grade 4 we've covered now, conditional statements in grade 5, and then efficient code in grade 6. So we're now into grade 7. So in grade 7, the new concepts that are added in our coding continuum are define count and subprograms. So taking a look at subprograms. So if we take our square that we made earlier, so I'll show you how to do that now. So here's my square. I'm going to now make a subprogram. A subprogram is like just what it sounds like, a program inside of another program. It also helps to break our programs up into smaller, more manageable pieces. It makes it more readable. You're abstracting ideas here, so using something called abstraction in computational thinking. So to do that, I'm going to go to my blocks, and I'll make a block, and I'll call it to square. If I can spell, there we go. Then click on OK. So now I have this new block called to square. I'm going to move just the square code up inside of that to square block. If I click the green flag now, it doesn't do anything. It just moved. It did sort of do something. It moved to the right direction. It's in the middle of the screen. It erased everything, put my pen down. But now I have this new block called to square that's generated. And so I just stick it inside of the code now. So now it will go through everything. After pen down, it'll say, oh, I have to draw a square. So now I knew what to square is. And just look inside of the define block to know what to square is. So we now have a subprogram called to square, and it will draw it for us. So you can see that the main program here, this is called the main program, is much shorter than when it was when we had that repeat block down there. So it makes it more readable, and it's more obvious what's happening. Right now, at this part of the code, it's supposed to draw a square. So it's more obvious to the programmer what's happening. It helps with debugging. It makes everything much more efficient. So something I've done for fun with this is have students draw a bunch of shapes so that they can kind of see the purpose of why it's useful. So let's look at what that looks like. So I have given this to, actually gave this to teachers to try. So when you run the code, it does the grass, it draws the sun, it draws the flower in the house. And then I'll say, okay, I would like you to draw or make a couple subprograms to draw a window or to draw a door on the house. So they can play around with that. And you can see I give some hints to that. And then there's my challenge there. Can they draw a tree beside the flower? So then I just wanted to point out that, remember that big long program with unit rates? Well, it looks much simpler if we use subprograms in our unit rate program, one called collect info, one called calculate rates. So just another application of subprograms. Just to mention a resource that's available, again, on TVO that I had created a while back, where the students can do a bunch of transformations. So, and then they can label it with subprograms like a translation, a rotation, a dilation. I missed one, but anyway, so you can see that they're here. Oops, I'm making a transformation block, a translation block. So I'm just altering my code. And then that way, so when they do the translation, it will move the butterfly, it'll glide the butterfly up, and then it'll glide it back down again. And then you can do that for the other transformations as well. So in that resource you can find, again, there's, for this one, it kind of walks you through the whole process of doing a whole bunch of different transformations in Scratch with the butterfly. You can have your students walk through it if you'd like. The final program looks like this. So we do that reflection is the one I missed. So reflection, rotation, translation, dilation. And then in our code, we have conditional statements. So I just want to mention that Gabriella Bowen of Hamilton Wentworth Catholic District School Board created a resource that goes along with this. So it's shared for you as well. So she made some cards, some sort of activity cards that go with that and make it a little more accessible for your students. And they have something to focus on to work their way through as well. So definitely check out that resource that she shared. In grade 7, also, we do defined count. So there's a resource, again, I want to share this with you just because it's already created, where we look at some code that generates a little bit of a pattern on our screen using the Cartesian plane. So when they go to the link, once again, you can see I have some challenges in the window or in the comment panel here. So when I run the code right now, it makes the little diamonds go up on an angle. And the first challenge is, can you alter the code to plot 5 diamonds to quadrant 1? So they're all in quadrant 1 right now. So instead of having 10, I'm going to repeat 5. So that's a pretty simple challenge for the students to do. But then it has them, can you alter the code to plot 10 diamonds in quadrant 2? So we're going to change that back to 10. And then instead of going up by 10, I'm going to go up by -10 to go the other direction. So they'll play around with this and eventually get it. When they move their way through, it eventually gets into a defined count, which I'll show you in a second. When you go to that resource, all of the, so I'll show you the defined count, but all of those solutions are provided for the teacher. So there's a student activity page, you just send them to there, but there's also a teacher activity page with solutions, and there are videos showing you what to do there. Because I know sometimes that's tricky for the teacher. So you have like the answer for you, and I explain how I do it in the code. So hopefully that's helpful for you. So we've done grade 7 subprograms. And then in grade 7, we also do something called defined count. And you can see here in my repeat, we're repeating until the X coordinate is greater than 50. So there's a defined count where we're actually repeating based on a certain condition. So that could be defined count. So our last grade now, we're in grade 8 now. The thing that is new in grade 8 is analysis of data in order to make and inform decisions. So since we already have this resource, I thought I would share this for you as well. But it is calculating the mean of a set of numbers in Scratch. So when you go to this resource, again, there's a student activity page, a teacher page, and some solutions as well, but there's some video tutorials that will walk you through how to do it. So when you get to the application, You can enter in some heart rate values. So the students can take their own resting heart rates, or maybe their heart rates after running, and then they can compare those values, and it will calculate the mean of those heart rate values. And they can change the code. They can then take this application and apply it to something else. So maybe they can calculate, and this is from the Ontario curriculum in the teacher supports, it says something about calculating the number of hours that you sleep at night, or the number of minutes. So then they could record that over maybe a week or two, and then they could enter that into their program, alter the code so that it's then going to calculate the mean of the number of minutes that they sleep per night instead of their beats per minute for their heart rate. So they go to the link and they alter the code, or they follow the tutorial to actually make the application themselves. So then they're writing the code, and then they're altering their own code to use it for a different situation. So everything's on there with extensions as well for your students to try out. So here's an example of using that for a new situation. So the code's really small on your screen, but what I'm doing here is I'm asking the person's age, and then asking them what would they like to train at. Would they like to train at 50 or 80%? So they can enter in a percentage. I calculate their the mean heart rate from the heart rates that they give me, and then I tell them whether they hit their target heart rate or not. So we'll ask them their age, and then it will tell them whether they're meeting their target heart rate or not, based on the values that they have in the table. So you can just alter the values in the table. So I told them that they should train harder because my mean was 135 and my training heart rate should have been 152 based on the age that they provided. Okay. So let's just go through the grades that we just did then. We did subprograms in grade 7, define count in grade 7, and then in grade 8, decisions. I showed you an example of calculating that mean is a really good data analysis. So just the last 2 slides here before I share a link to a survey. I'd appreciate if you could fill out the survey, but I've got some assessment cards for junior grades and then some assessment cards for intermediate grades. So just taking a peek at the junior grades, you can take a look at the others, but it's just like a Google slide set slideshow, and it includes programs or some questions for you to consider, and also includes the curriculum expectations on the bottom. So here's an example. It says code for 2 programs is shared. The output is the same for each program. Describe the output when the code is executed. So they actually predict what happens when the code is executed for each of these. And if they've been doing shapes, then they should be able to do this. Which code is more efficient, and explain your answer. So we're actually also connecting to grade 6 there. So there's a number of other activities. There's a question about 2-sided coins. So they can compare the code and explain. So again, they don't actually have to go on to Scratch to program this. They've already done that. Now it's time for the assessment piece. So they've got screen prints of code. It's much easier to assess, much easier to give feedback as well, because it takes a long time to go into every single student's program and assess it in that way. And also everyone does it in so many different ways. So it's hard to assess student programs. It's easier when you do it like this, and you can even interview the students and they can talk about what they see on the cards. So in summary, we did sequential events, 1 line of code after another in grade 1, concurrent, 2 things happening at the same time in grade 2, repeated in grade 3, nested events in grade 4, conditional statements in grade 5, efficient code in grade 6, subprograms in grade 7, define count in grade 7, and then data analysis in grade 8. But we also looked at the things that are the same in each grade, which is to write code. And that second expectation is what we really focused on today, reading and altering existing code and describing how any changes to the code will impact the outcome. So if I just change this number, what will happen? And those are questions you can ask your students as you walk around the room. So I do have the link to all the resources from today's webinar. It's Floyd Math, so bit.ly/Floyd Math. There's also a link to a survey on there. So I'm going to share that link with you. And I'd really appreciate, again, if for those of you who have been attending some of these sessions, it does validate, getting feedback. It helps me as well when you share feedback. It's not too long to complete. So I really appreciate if you can fill that out for me. So I'm just going to go through there. So here's my survey. Oops, I don't know what, I almost shut down my system. There we go. So the survey is here. And then I'll type in the link. And there's the link to all of the resources. So thanks so much again for joining on the week before, for most of you, the week before March break. I'm going to stay on for a couple minutes, just a few minutes here. So you're welcome to complete the survey. Let me know if you have any questions. I'm going to read through the questions. I'm sorry I missed a couple questions. So I'll answer those questions now. And I see a DM from Julie. Thank you about that. So Julie made a suggestion to my French resource. I always appreciate. So any resources I share, I really appreciate like sharing back or letting me know if there's something that we can change, especially if you try it out with students, because they always have suggestions. And I always think, oh, I have such great ideas. And then the students make it so much better, or teachers make it so much better. So always appreciate feedback and help to make things better. And it's nice that Maureen tried that out with the class. Awesome. Hopefully it went well in the class last week. Moving through the chat window here. No dumb questions, Andrea. How do you embed the instructions challenge note right in the Scratch workspace? Oh, so the right click. So that little challenging, I just right click on the code editing window and then it says comment. So that is how you can write a comment in there. And I find that super useful because you don't have to constantly interrupt to students as they're working. They just look and they know exactly what to do. And they get used to that. No problem. Thanks so much for joining, Julie. And thank you, Tanya, for joining. Thanks, Andrea. Thanks, Christiana. Great to see you on here again. Lise, you came again. Thank you. I know yesterday you said have a great March break, so I wasn't sure if you'd be joining. Hi there, Bobby. It's nice to see some representation from one of my children's school. Two of my good kids go to Cattery, and I see Bobby on here. Thanks. So have a wonderful, for those of you who are going to be having March break next week, please enjoy your time. I hope you get some time away from doing work. Thanks, Patty. I'm glad it was helpful. Also, all of these are archived. So you can find them on the OECM website. This one will be up in a few days. If you'd like to check out any of those links again or an explanation, also send me an email if you have any questions. Great to see you, Christine. Haven't seen you in so long. Glad it was useful. So I'll stop here. All right, so I don't see any more questions. Have a wonderful week. Take care, everyone.